standard type file extension. On a lot of printers and a lot of embedded devices, you can actually just query for that and it'll give it to you without any requirement for authentication. So what we want to look at is the Canon. What's interesting about the Canon printer, we're going to be looking at the address books on this device. Canon printers and a lot of other devices, the address books contain more than what you typically expect an address book to contain, or they can. We normally expect to see, username, email address, phone number, typical stuff like that, maybe some fax information. Well, it turns out on this particular device, there's a lot more information. So let's look into forceful browsing, gaining access to that. Again, the extensions on this device, or the files we're after, are .ldif or .abk. Very non-standard file extension. So maybe that plays a role in why we can get access to it. The image runner actually has 11 address books, or up to 11 address books that you can query on it. So if you type in this URL, you should be able to extract it. But first thing you got to do is you have to have a valid cookie to be able to do this. So if you just type in this URL and point it to your image runner, it's going to fail because you don't have a valid cookie. Now, I didn't say an authenticated cookie. I said a valid cookie. So if you hit the home page on the printer, it will give you a valid cookie. And then enter this in, and it'll give you the first address book. If you increment the AID up 1 through 11, you can get each and every one of the address books. The data that typically comes off the address books is in plain text. Also, a quick note. Early this year, I had mentioned that I thought this was patched in a lot of devices because I was getting failures on a number of occasions. Well, I started analyzing a number of image runner devices, and I noticed that these two models here, these product name IR3580 and IR4080, are the only two that I can find that this fails on. It works on all the others that have this address book functionality. Not that there may not be a way to get around on these devices, but this method fails on them. But it doesn't fail on all the other ones. So let's look at this data. So we pull the address book. We can quickly see that URL information, a username, and a password can actually be pulled out of the address book. So what are we looking at? This device is actually configured so you can walk up to the printer and do a scan job after you authenticate yourself as D. Smith. And what it'll do is it'll do the scan job and it'll save it on your workstation. That URL happens to be his workstation. I've also seen these configured to point to actual file servers. But predominantly, I see it pointing to the individual's workstation. So he can do a scan job and it shows up on his workstation. So now I have the password to his workstation, so I can log on. Well, if they screwed that up and they actually created the username of Canon as an administrator on his local workstation, the next step is I'm admin on his workstation, which we've done before. At that point, I can extract the hashes associated with all the users on the device, particularly the administrator account, and use that to break in on every other machine on the network that actually has the same administrator password. So the next thing we want to delve into is backups and cloning. Backups, the purpose of backups and cloning is ability, one, to make a backup of your configuration of your device, which is very important if you need to fix it or rebuild it or whatever the case may be. Xerox really does what they call cloning. It gives them the ability to roll out multiple systems. So if you're rolling out 50 Xerox boxes, Xerox multifunction printers in your environment, you really don't want to go to 50 devices and configure them. So you can pull a clone off one device that's configured and deploy it across all these different devices and configure. It's a really nice process. So the whole idea of this is if this contains information that we could use to attack you, then of course we can log on, pull this, and voila, we have usernames and passwords. So let's look at the first one. This is a Lexmark. The settings, import, export setting file functionality, and this export file is all in plain text. So we easily go to this page, import, export. We click export setting file, and we're able to extract this, and as you see, plain text passwords are actually stored in this file. The interesting thing about this device, this particular device that I tested, was that they've done a really good job of not having information leakages. So when you go to the configuration pages, you can't extract the passwords out of the source code. So they've made an attempt to actually secure the device from that level, but yet have made it possible for you to actually pull all of the configurations, including usernames and passwords, off the device in a backup file. The next one we want to delve into is the Xerox. Fairly simple. If you go to log on to a Xerox Workcentra, and what's the password for a Xerox Workcentra? I don't know if I heard it, but it's 1111. That seems to be the normal for the Workcentras. Username is admin. So we get to this, we go to the Xerox Workcenter, general setup under properties, go to cloning, and we have all these settings that you can select to extract the cloning data. You click on that and you get a cloning.dlm file. You right click on this and you can save this. So what is a DLM file? So let's go ahead and show you. Before we do that, the previous example with the Lexmark, we noticed that it exports everything out in plain text. Xerox used to do that. They fixed that problem. So the newer stuff, the outputs of the DLM, is actually the passwords and encrypted. So we're going to show you the older stuff, the newer stuff, some conversation around that, and where we're going with that, and how to get access to the DLM data. Everyone see that good? Everyone see that? It shouldn't be. Let's see. I can't control that. So a typical DLM file that you extract off this, let's go ahead and look at the DLM file. As you can see, it looks like a whole bunch of compressed, encrypted, it's some kind of data with a header, somewhat of a PGL type header. So I really didn't know what the format of this was, so I spent some time on the internet searching around, and I search and I search and I search. And I finally found a message board out of Norway, all written in Bork, which I couldn't read, but I knew they were talking about this. So I actually fed it through a translator online, and basically the gist was, and it was between two Xerox employees, thank you, that this is nothing but a tarball. So if that's the case, let's just get rid of this header. Maybe I need to. Oh, need how to spell DLM. There we go. Okay, they were able to extract it. So it was a tarball. The item of interest in this particular extract is under data. So if we search down through there, and obviously you can see it's the entire configuration, mostly in plain text. Go down through here, looking at all the passwords. There's one, and there's one down here. So we instantly find that the LDAP password is like milk dud. So we're able to extract the data. Now this is what they were doing several years ago. They've actually fixed this, which is a good thing, and that's what this is all about anyway. It's about security, not insecurity. So I like to see companies moving in the right direction. So let's go ahead and look at the other example so we can see what it is. We've already extracted that, so. And as you can see, it's some kind of encryption. And I have to admit, the first time I saw this, I thought, oh, it's just an MD5 hash or something like that. But the truth is, remember, this is the LDAP password. So it has to be some form of encryption encoding. We haven't cracked this yet, so I'm just throwing it out there so you can see this and see where we're thinking, we're moving forward. This has to be some kind of encoding or encryption of the password. It's 32 characters hex. We also know that it's a clone, so this has to have the same keys or the same encryption process on every one of that brand of printer, or the clone wouldn't work. So we know that much, so it's consistently reused. Research I've done so far up to this point leads me to believe that the cloning process isn't the part that's encrypting this, that more than likely the encryption mechanism of this is actually being maintained within the Postgres database that these devices use, using some type of Postgres encryption, and that's where it's being handled. So that's where we're at on that right now. So as we move forward, anyone interested in helping me with this down the road, shoot me an email. Definitely open to getting some assistance. Okay, the next area we want to get into is the passback attack. This is something I've just been working on, I don't know, over the last 4 or 5 months, and it's kind of cool and kind of fun, at least I think it is. So the whole idea of a passback attack is an attack where we trick the multifunction printer into communicating to us, the attacker, versus his configured service, as the example. A number of printers we found have a test function on them. So if you go to the LDAP configurations on certain printers, you can hit a test button and it will test the actual authentication of LDAP to the configured LDAP server. And there are some other services that do this also. So the whole gist of this attack starts out with the attacker hits the test button on the printer authenticates to the LDAP server. The attacker changes the LDAP IP address, hits the test button, the printer nicely authenticates to the attacker, giving us the ability to capture all the authentication data. So let's start with a couple examples. The first one we're not going to get into a whole lot of detail, but the second one we're going to show you a lot of detail. It turns out here on this Sharp printer, if we look at each one of these possible settings on the configuration page, every one of those is passed from client side when you hit the test button. So they are, you have the ability to alter those from the client side versus server side. The Sharp printer has the ability to do this on LDAP and SMTP. And like I said, the attacker can send all of these fields except the password field. The password field's stored on the printer. So if you can tell the printer to test this using what you have stored on the printer as the password, you get the plain text password. These are the 3 fields on the Sharp printer that we want to alter: the server IP address, the auth type. Because remember, it may be configured to do NTLM or Kerberos, but during the test function, you can say, let's just do it in plain text. That way you capture it back. And here is the screen for the Sharp for the SMTP settings also. So the next we want to get into, we're going to show a little more detail, is the actual Ryko printer. And the Ryko printer, very similar to the Sharp printer, easily to trick into doing this. So if we look at the configurations, of course, we have the server IP address, we have the port number, and I reference the port number because if you're attacking this device and they have filters between you and him, that particular port may not make it back to you. So if you can alter that, you can get it to go across any filtering they may have. And of course, the authentication type, as you see we have set there, clear text, digest,